You've used a ruler hundreds of times. But look, right here, before the zero, there's a gap. It's not lazy printing. It has a name. And once you understand why it's there, the tape measure in your drawer suddenly gets a lot more interesting. And the people who use these tools every day, they stop using them the way you do. There's a reason carpenters never start measuring from the end of a ruler. See, the second that tip is even slightly off, every measurement you've ever made is wrong. That gap before the zero, it's what engineers call an end allowance, a buffer. Even if the physical tip breaks off entirely, your zero is safe. The measurement starts there, not at the edge of the material. That's a designer thinking about failure, before failure happened. But that's the easy version of the problem. The tape measure on your desk, it's solving a much harder one. Go grab yours. Wiggle the hook at the end. It's loose. And when you hook it onto a board, where exactly does the measurement start? The outside of the hook? The inside? You know, those are different numbers. If that hook were welded in place, your tape measure would be wrong. Wrong outward when you hook it onto an edge, wrong inward when you push it against a wall. Same tool, two opposite errors. So they made the hook loose. On purpose. The slot it sits in is exactly as wide as the hook is thick. Pull, it slides out to compensate. Push, it slides in. The 0 point is always at the surface you're measuring from. One loose piece of metal, two opposite problems, solved by the same wiggle for 150 years. 150 years isn't even the start. Long before any of this, people measured with their own bodies. The inch was based on the width of a thumb, or 3 barleycorns laid end to end, depending on which medieval king you ask. The foot was, well, a foot. The cubit, elbow to fingertip, built the pyramids of Giza. The Great Pyramid's base is consistent within a few centimeters across 230 meters of stone, using a stick and a piece of rope. Modern rulers are fighting physics. They're manufactured slightly longer than their marked length to account for thermal expansion. On a hot day, your ruler is measurably bigger than on a cold one. And here's the thing, even with all this engineering, the gap, the wiggling hook, the thermal compensation, ask any carpenter how they measure. They don't use the zero. They don't even use the hook. They start at the 1 inch mark and subtract 1 from every measurement. They call it burning an inch. The pros still don't trust the end of the tool. Oh, and that little black diamond every 19.2 inches on your tape measure? That's not decoration either. But that's a different video. Look at the pull tab on a cardboard box, or the slight ridge on a bottle cap, or the recessed power button that's hard to press by accident. Every one of these was designed by someone who asked a question most people never ask. What happens when this goes wrong? The gap before zero isn't decoration. It's an answer to that question. So is the wiggling hook. So is the slightly too long metal bar. So is the carpenter starting at 1. Good design is mostly invisible. You only notice it when it's gone. Which means right now, all around you, there are hundreds of tiny solutions to problems you've never seen. You just have to know where to look. If you're a carpenter, a machinist, or a tailor, you already knew most of this. The rest of us just learned it. Next time, why does the hole in the middle of a CD exist? The answer isn't what you think.